Here we are, and this is supposed to be a quiet week. I don't think there is a quiet week. The week started with a new model. It's exciting as any other week, I guess. I love living in the future. What do we got lined up today, Rob?
We got a few folks get some updates from Brad and Chris Royce is joining us today, and then lots of announcements and stuff going on. Stockholm just had their event. Robert Weston and Gunnar out. They had a event just yesterday that went off really well. So we're all prepping for Tokyo. That's December 3rd. And then, of course, the hackathon's coming up next week, so we can get into that a little bit later as well. It is a busy time to cap the year, I tell you. It's been quite a crescendo, and also the Toronto meetups is December 9th. So all of the above.
And we've slightly rebranded our hackathon to Media Gateway Hackathon. Big companies, big logos, big names, and lots of finagling around that. So my apologies for sort of sending out the wrong logo. Google led me astray. What can I say? But we got the right logo in there, so and we really do appreciate the support of TB5 USA, and it's five. They told me it's five, so I'm allowed to say five. It's saying when we're
Very
in
good.
With France, it's saying, but this is USA, so it's TB5 Monde
Yep,
USA. All right.
that's right.
Thank you to them. We got Google as a supporter as well, and our friends at Kaltura who are going to be letting us use their system for all the various, I don't know, the
Studio setup.
videos and studio and
Yeah,
yeah.
it's excellent.
Zohar has been amazing. He's Kaltura has supported us since day one, by the way. So they're the OG of OG in our crew. So really do appreciate all that they do for us.
That's
And the
right.
video.agentics.org site is also powered by them. Cool
Yep.
stuff. Yeah, so it's a bit of an open session today. It's a holiday week, so we'll see how we do for people showing up because half the people probably are doing holiday things, which from the US. But for the rest of us who are not in the US, it's just another Friday for us. But for those that celebrate, happy Thanksgiving.
Hmm.
Lots of football on TV yesterday.
Yeah. Yeah, I did great. I have CD Lamb in my on my fantasy team, so it's always good.
All right. Yeah. And so yeah, that's I can't say I spent a lot of time watching football, unfortunately. I'm the guy that shows up for the last game. But I've got other things that I devote my attentions to, which I'll show you guys this week. But I think the big news is 4.5 Opus.
Uh-huh.
And it's a good model, but it's a good model for not the reasons why previous iterations, like the jump between 3.5 and 7. 7 was a weird, 3.7 was a weird model, right? It was really good at like the like sort of technical capabilities. And it struggled with like guidance and tone. It had all those stupid M dashes. The M dashes, at least for me, are gone for Claude 4. Opus 4.5. I haven't seen an M dash all week, which is a major plus. And it's got a different t timbre, voice, sort of resonance. Like when you interact with it, it feels different. Now, I don't know if it feels smarter. Like some people are like, it feels smarter, it's more capable. I haven't noticed that it feels any smarter or capable, and I think that that's a byproduct of the memory systems in Claude that they're using that kind of know me pretty well at this point, and all the sort of manipulation I've done to it. So I think that from an intelligence point of view, I think we peaked probably in July. But from I don't know, like a voice, the way you sort of feels when you interact with it, that feels different to me. I don't know. Anyone else have any thoughts on the model beyond my things I can't measure? Be interesting to hear what others' opinions are on this. Have you played with it at all, Rob? Brad?
I haven't
I,
had
I
a
was
chance to yet. I've got it up, but I'm sure Brad, you go ahead.
I was going to comment. Yeah, I think yeah, this summer or even 4 point when ChatGPT 4 came out, I think we kind of hit that plateau of it was all about stuff that you've been teaching and we've been observing, where it's talking to yourself and reasoning models and adding personas, so having a voice So I think it's very incrementally better. I like it. I keep using Claude, the old school chatbot. I find I run out of content length pretty quickly when I'm using it, but I like it.
Yeah. The context is interesting, and they still don't enable the million context for Claude Code, which is a shame. Now, for those who have played with it, that's why you use Gemini. Then, and the big difference in Gemini 3 is also a spectacular model, I might add. I
Hmm.
think it's a toss up, but the million content, or I think it's a million for Gemini, puts it over. Like if you're doing interesting things that require a lot of information, you just want to sort of, stuff it, Gemini is where you go. Now, I see a comment on Codex Max. You know, I like Codex for certain things, but I keep coming back recently. I just come back when I'm like vibing. I just like when I'm on my phone and I'm killing some time when I'm not in front of a computer. I spend time on my phone. I've got issues, but anyway, I pull up and I've used to use Codex for that, and Codex was okay, but now the code web options in Claude Code are better. I can spawn 15 concurrent agents. They actually work reliably. Any of my .claude files that I've already have in my repo just magically work. All the settings.json files that do the hooks magically work, and the skills and the agents and the commands all magically work. And now it supports MCPs and they work. So as long as you include your sort of ideal Claude Code setup, it just kind of just magically works in Claude Code Web. That and so a lot of the little things I'm doing, I'm just popping in the Claude Code Web and saying, fix that security issue that someone sent me, or do an update that uses the new guidance for MCPs from Claude. And that's literally what I'm going to do on the updated version of Claude Flow later this afternoon. I'm just basically pointed at a blog post that the Anthropic guys did and said, do that, test it, validate it, and create me a patch release. Never even opened up VS Code to do that, which is a pretty nice feature. All right. So in terms of what you want to cover here, we have a kind of loosey-goosey structure here today. I've made some pretty interesting, I don't know what you want to call it, breakthroughs in the kind of combining the concepts of a graph neural network, vector space, and sort of an episodic memory compression to create something totally new, at least to me. I couldn't find anyone doing anything like this. So for a game, I want to just kind of walk through some of the stuff that I'm doing there and kind of some of my excitement around it. And this is going to likely form the basis of an update to Agent DB that I'm currently doing in the background. Once I create the update to Agent DB, that will automatically propagate to Agentic Flow, which also uses Agent DB and Claude Flow. So everything I'm going to show you is going to be integrated in the Claude Flow here at some point over the next couple of days. And I don't know what that's going to do, but I think it's going to do some crazy stuff. So I'm going to let me share my screen here for you guys quick. And if you have any questions, again, just jump in and interrupt me. I have a tendency to ramble, and I don't mind being interrupted. All right, here we go. All right. So I'm in Root Vector. So some of you tuned in yesterday would have saw a lot of me ranting and showing. This is a little bit of a rehash of that. But in terms of Root Vector is the sort of amalgamation, the combination, the culmination of all the things that I've been working on over the last, I don't know, several months. And you'll see that there's like sort of these various structures that I've sort of discovered and used and combined. So essentially what I'm doing is I'm combining three essential patterns, right? I've created a new vector system. It's not novel. It's basically just a faster sort of, Rust-based vector engine. It's very similar to Quadrant. It isn't Quadrant. And the reason it isn't Quadrant is because I wanted to be able to run this in user memory as a WASM. Quadrant doesn't do that. If I want to embed this in your browser or run this in your local environment with no requirements, Quadrant doesn't allow you to do it. You need to use a Docker instance. It's a heavy duty sort of install. This is the opposite end. This is meant to say, if I want the system to learn, it can learn through a federated broad global network, but it can also learn independent of a network. It can be embedded directly in your browser, and it can get all the benefits of learning without ever communicating back to the sort of primary environment, which works great for privacy, works great for GDPR. It works great for things where there are concerns around AI policies and having that information owned and separated from the parent company or parent provider, which is unique. The next is I took the concepts of the vector, so high dimensional space. I created a hypergraph structure. So unlike Neo4j, this system inherently uses multiple dimensions that allow it to understand information flowing in a pattern that mimics a synaptic network in your brain. Multiple things interconnected and using high-speed pathways to navigate that. That allows us to scale tremendously, trillions or more of interconnected relationships without overwhelming the system and making it so heavy and large that you can't effectively run it. So I'm compressing. Then the part that was interesting is I took the concepts of an attention-based network or tensor and then applied that in the structure of the index that combines the graph and the high dimensional space to create a kind of awareness that allows it to understand itself and its thinking patterns and self-optimize those components. So you'll recognize some of that from the work that I was doing in like the dspy.ts and the agent DB self-learning, but I've taken that and I've super optimized it with an actual GNN. So those previous versions were essentially a kind of reinforcement learning that I would apply, giving points up and points down, and I could navigate within the construct of a SQL-like database. It was cool and it worked really well, to be honest. And anyone that's been using Claude Flow over the last month or so has noticed a particularly good increase in the ability for it to code over time. So the first day you use it, it's basically Claude code. By the 1 week in, it's like an X factor of more capable because it's learned on all the things you've done in Claude code. Every edit, every question, every update, every push gets saved into this structure, and the system is intelligently utilizing that information to optimize how it creates for you. So in some ways, what you're seeing in the development of this platform is the very sort of self-learning and evolving capabilities that I've infused with AgentDB and put in the Claude Flow to create this kind of amalgamation of all these sort of new discoveries that I've made into a newer discovery, right? All compacting on each other. And the next part was there was this idea that we needed to scale to huge volume. For the hackathon we're doing, these guys said that we need to figure out how to handle, 400 million users or something crazy like that, and billions of hours of potential understanding. Now, to do that kind of scale requires an exponentially large compute capacity to do that. So when I first looked at using Agent DB to do that, it became clear that it was great when used on a single individual basis, but when used collectively across hundreds of millions or billions of agents that are simulating and understanding and predicting what a person wants to watch, it would become just too costly. And when I say too costly, we're talking about $1 a user a year. But at 400 million users, that's $400 million, right? So on smaller segments, it's fine, but on larger, it isn't. So to overcome that, what I needed to do was create a mechanism that essentially allowed it to scale to that kind of level, which I did, and using Claude or actually Google Cloud. Then I needed a mechanism to handle sort of the compression of that information because it was creating an astronomical amount of information. So let me jump to that. So this is what it looks like. So this is the GNN query. This is traditional. You're making a query. If you're hyper optimizing, you're using the HNSW. And you can apply that, by the way, to like Supabase, anything. If you're using any form of vector database, you have to use this particular it gives you like 100x improvement in sort of query time. But once you have that, then I can embed the GNN layer and then have that recursive loop that basically optimizes itself based on interacting with the information. Now, this is happening in a really, really fast period of time. So it takes your initial query, finds its their nearest neighborhoods. So much like your brain, it's segmenting the vector space into multiple areas of a kind of I call it neighborhoods, like the area of your brain that allows you to talk, the area of the brain that allows you to remember, or allows you to feel, right? These are different neighborhoods within your brain. This system is segmenting in the same way and allowing you to navigate those parts. Then it applies the idea of a GNN. And what a GNN, the graph neural network, basically takes this idea of attention, multi-headed attention, and then allows it to sort of automatically discover and have a kind of self-awareness that's directly infused into the graph and vector space. And then based on that, it creates a kind of auto enforcement of what's good and what's bad in the same way that you would learn to play an instrument and you get this kind of brain-based muscle memory. The more you play, the better you can become. The first day you do an F chord, you're debating whether or not to do the F chord as a bar chord or using your sort of your fingers a little lower and trying to do the E form and all that. But over time, you instinctively know the difference between the different ways to do an F chord, right? And that becomes instinct, right? That's how you're training your mind. Similarly, that's what the system can figure out. It knows that there are multiple ways to do an F chord. It knows that certain F chords are better for certain situations, but it applies that to genomics. It applies that to the interconnected relationship of documents, to allow it to understand why and what in a way that a language model, which is only applying it to what the next word is, can't. And it infuses that using mathematics, vector, vector-based mathematics, rather than in the attempt to say the most probable next word based on where it is in a sentence or paragraph or some larger context, which works for like interpretation, but sucks for anything involving any real pattern-based activities, actual learning, or anything that needs to be light and fast and memory efficient. So lastly, the problem is data. So when you're doing models of billions of things, the ability creating massive amounts of data, you can't remember all that. In much the same way that can you really remember what I told you on AI Hackerspace last week? Yeah, there's some things you probably remember, but the finer nuance of what I said and what I did is lost. But you remember that you were there, right? You remember that you tuned in and heard me talk. So what this does is basically uses the same concept of how we remember information using a compression algorithm that just came out, which I applied, called tensor compress. So the tensor compress model, it takes this idea of the things that are most relevant and up to date now, and then allows you to use those in the form of, no compression. What I just told you 5 seconds ago, that's fresh in your mind, not compressed. Then as you go back, what happened a few hours ago becomes a little blurrier. What happened yesterday, less. What happened last week, and so on and so forth. So you get a point where it's able to compress that information while maintaining the relevant parts of that information so it can be queried within the different neighborhoods it exists within in the structure, as well as how to get to it quickly through that sort of small world navigation, the H and blah blah blah. So that allows you to get the information ridiculously quickly. It allows you to understand it, adapt it, evolve it. So that's what I've been building. So we've got this idea here of low memory. This is in microseconds. So, thousands or hundreds of times faster than any. This is probably the least important part. I've included the Neo4j cipher component, so it's instantly compatible with Neo4j. The information exists in hypergraph. There's learning, there's AI routing, there's massive global scale. I did some initial testing here, and the cost reduction, for example, for 500 million users who need to remember what their preferences are for television, we go from $50 million a month minimum to $1.7 million a month, which means the difference between $600 million and probably 20 million bucks a year or less. Right. So it's way more scalable. Now, as you guys know, I've been building these things in a modular form. So what I've done is I've taken all these bits and pieces and I've created a kind of plug and play approach where you can pick and choose the different parts that you might want to use. So you've got kind of the core. I mean, most of the stuff is stuff you're going to want to work with, snapshotting for obvious reasons. If you're doing versioning, performance metrics, everything you're going to do in the system needs to be measured. Now, unlike a traditional language model neural network or monolith, that black box is exposed. We have a graph that shows everything in terms of how it's thought, how the process it went to get to that, everything that the temporal elements, where it started and how it evolved to the point in which what it is all visible through the system. And you can query it, you can understand it, you can visualize it with graphs and other systems. It uses Neo4j. Any graph structure that's compatible with Neo4j can actually show you the inner workings of the mind of the system. I've built it all to be both, efficient from Rust, so you can compile it yourself, but you can also run it in the browser. You can literally run a GNN in your client-side browser on a little thumb drive, whatever. I've separated the distributed systems, so if you don't need to run for 500 million people, you don't have to. You just plug in the components as you need them. The AI routing system, this tiny dancer, which is also just crazy, this does millisecond routing based on a secondary form of AI that acts as a learning mechanism to figure out where and how it should relegate or delegate the different types of AI it has available to it. So it might decide that it might need open router and a Kimi K2 or what have you, or it might decide that it might build its own AI just long enough to do whatever it needs to do, a language model. So it's capable of using that sort of quick routing. There's a semantic router which routes based not on the specifics but on the generalities. Like we did similar things, we had similar problems, there's similar correlations. This works great for the sort of correlation between, for example, a genome and your microbiome or your stomach bacteria and how that affects how healthy you are, right? So, and you can do that in an instant. And in a test I did the other day, I was able to do the entire index of a full human genome in under 100 milliseconds. I need someone else to go out and do the same thing and prove that I'm not hallucinating this and I'm not a crazy weirdo. But essentially, what that means is the state of the art for current genomic sort of analysis takes hours. I'm doing it in milliseconds potentially, right? Correlating and understanding, finding pathways between the different components. I've also
Just a
then
quick
packaged.
question.
Sure.
Sorry. Yeah, the data, is it from Kaggle or how did you get the sample
I
data?
I went to a university and downloaded the genome
Ah,
and
nice.
then fed it to the system. I've got some systems. I've got some benchmarks too I can share with you guys. And I'm sharing some of the benchmarks on my gist. And there's an examples folder. I will probably publish the entire. Here's the bio. Yeah, here's some of my. This one I did are RNA sequences, but I'm getting just incredible performance. So this is, I'm doing, this one's doing in 8 seconds for 100,000 sequences. Just like what? 10 million sequences. It took me 13 minutes. Like you can comfortably do entire populations of genomic research in literally minutes. 100,000 people, 10 million people compared in 13 minutes. Like just the most bonkers things possible. And then correlate that, create a graph, a self-learning graph and vector space that finds interesting novel discoveries within the structure of that vast pool of data that would be normally brute force through GPUs. This is using a freaking CPU. This is all a CPU. So then I compared it against, a friend of mine who has got access to Blast, and there you can see the difference is just like it's not even the same galaxy. And Blast is using GPUs. So what we're talking about here is the ability to quickly understand really complicated interconnected relationships of just about anything. Like hypothetically, we could simulate every person on the planet like in high fidelity and see how they interact with each other and then do various types of modeling that says, How does climate change affect them? How does a potential disease that's outbreaking in a certain place affect them? And we can do that instantly. And this is the type of stuff that we're sort of open the door to do. So all you're seeing right here, I'm in the process of implementing into AgentDB, which I just started. Let's take a look what's going on there. So now we've got, and this was running while I was talking. I started at the top of the hour. All right, what we got here? AgentDB Alpha 2 implementation complete. I've successfully spawned 12 agent implementation. What I want to show you guys is how I got to this. Just I thought you might be curious. Actually, let me pause for a moment. Before I go into like how do I build the crazy stuff that I build, any questions on the previous crazy?
Yeah, Ruv, I've got a question. You said that Cloudflow obviously learns, right? I mean, maybe this is a basic question, but if we are instantiating Cloudflow for different projects, obviously it's a fresh install when we basically do an npx or an npm. Is that something that we should bear in mind so that the learning from the previous project percolates to any new projects that we are progressing?
I need to figure out the migration path. So what I think I'm gonna do is if you've previously installed Cloudflow and it's an existing environment, then I'm just gonna divert or have you use the original AgentDB structure. I'm not gonna force you into sort of a new paradigm and potentially corrupt the old one. So what I'm gonna do here is for new users, you'll just get the Cloudflow update, or if you want to run a migration, maybe slash migrate or something, it'll then take your old and then migrate it to the new environment. But I'm not going to force it on you. Like I generally force you to get my most recent. Like that's how everyone got AgentDB. And to be honest, that's why AgentDB has got as many downloads as it has, I think, is because I did a kind of npm, injection attack with my own stuff. Yeah, so I'm getting 17,000 downloads. The 17,000 downloads a week basically shows you how many downloads of Cloudflow I'm getting a week, right? Because I'm essentially injecting it into that. I'm I'm gonna do some injection. You got until the world stops me. That's the quickest and easiest way to do it. But you'll have to invoke it, and I'll do a blog post, and maybe next week I'll show you how I'm gonna do that. I digress here a little bit. All right, so let me show you how I actually did this. I think this is interesting. All right, so again, I'm on my exercise bike. You guys know every morning I get on my exercise bike, keeps my brain working and keeps me from being too, I sit in front of a computer all day. All right, so on my exercise bike, I just finished articulating my post about how crazy the stuff is that I've made today. And I talk when I make those posts, by the way. I use Claude Code Voice and I just blah, 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 kind of like what I'm doing right now. And after I finished that, I said, how can I use the MPX vector, in related packages in agentic flow, do deep research and put in plans/vector. So it did its thing, went through, and you see it's creating the documents. It knows that I like to use Spark and whatnot. It said I asked it what are the benefits and disadvantages. It says that tiered memory is good. This is interesting because it uses the GNN. It's smaller, way smaller. So I'm going from 4.1 gigs to 10. This in itself is a major win. And one of the problems with long running projects using Cloudflow is you get bloat in the SQL-like database. Anyone that's done a month of work with a single project knows holy that project, my DB is getting huge. That solves that problem dramatically. Learning graph, all the crazy stuff. I can do distributed swarms, and all that sort of. And so I'm trying to understand what I'm going to do, how I'm going to do it. Here's my sort of SWOT analysis. Bottom line, if you need sub-millisecond search latency, adopt it. We're so fast that at this point, we're going from milliseconds to microseconds to nanoseconds, all of which are happening infinitely faster than we can even perceive. So I keep trying to push the boundaries, but to be honest, it's probably not that important. The real important part is the ability to understand and learn. So, I'm pushing it down that direction and saying, how am I going to do it? Single deployment management. Agent DB handles root vector, like et cetera, et cetera. So this is me on my bike. So I'm just trying to figure out exactly what I want to do and how I want to do it. So this is literally this morning. Bottom line, integrate agent DB if you want clean abstraction. All right, create and integrate into, a benefits package. Some more, I'm using 384 dimensions. That's kind of my go-to for this. It's light, doesn't require any kind of vectors, or sorry, GPUs. I'm trying to stay under the requirements of having to use GPUs for vectors. That's why I have a tendency to use 384. It's the best for that sort of use case. Now, if we added a GPU to this thing, who the hell knows what we're gonna do? Maybe we create AGI or something. I haven't gotten there yet. That's a project for another time. All right, so now let's integrate as an optional init flag, and I've got some sort of details here on that. I'm getting some feedback from someone. One sec, guys. Let's see what we got here. All right. Unmute all. I'm muting all for you can unmute yourself if you want to talk. Just give me some feedback in my head here. All right. So at this point, I added this. This is sort of, create a plan, create it in plans, agent DB v2. So I started thinking I was going to do it in agentic flow. Then I realized, no, it makes more sense to do it in agent DB. So once I realized that, I sort of pointed at that. While I'm at it, I might as well fix any security issues that I have. Probably things have come up since I first did it. So I want to do a review. Code checks. Went through it, spawned it, did all these things. All right, at this point, it finished, and I gave it some, what am I building here? Seriously, is it innovative? Like, it's the question you ask yourself on these things. Am I BSing myself into an elaborate hallucination and simulation of something that is not true, right? And AI has a tendency to be a mirror of a reflection of the crazy that you give it. And what I don't want is this to basically just reinforce my own crazy. So I'm trying to be a little bit critical. It's a serious attempt at agentic infrastructure, the plumbing of multi-agent systems. It is an AGI, but even if it was, how the hell would we even know? The bet you're making is the future of orchestrated agents is not bigger models, but that whoever builds the best coordination layer wins. And you guys know that's my mantra. And the competition, I don't think the competition comes close to this. We're talking LangChain, the simpler, less infrastructure. This doesn't have any agent focus. All right, this looks pretty good. At this point, I jump into VS Code. All right, and this is where we start. All right, so why is it the home button's inverse? All right, let's go back here.
I got a quick question for you, Ruben.
Sure.
Just earlier on, like 45 seconds, there was a decision point you had to make between Agent DB and Claude Flow. And so do you see the
Agentic flow.
agentic flow, right? So do you see those two as competing alternative ways to do the same thing?
No, so there's a cascading series of dependencies. So you notice here that I'm in the agentic flow library or repo. And so agentic flow is the core logic and structure of the Claude Flow system that includes the integration of the reasoning bank and the ability to spawn agents, to be able to use multiple different language models like Gemini and Open Router and things like that, and a whole variety of other things, and a bunch of Easter eggs that some of you have found and others haven't, but lots of stuff. And then sub to that, so agentic flow allows you to operate independently. So if you want to create a swarm of autonomous agents that run perpetually forever, Cloudflow basically is geared towards interactive sort of interaction, right? You're asking a question, you're saying go spawn a swarm, go do these things, and it goes and does it. But for a lot of applications, you want to run it, in perpetual motion forever. Agentic Flow allows you to take all the things you're doing in Cloudflow, the Cloudflow agents and the helpers and the skills and the settings and all those things, and have them run in basically a cloud-based environment or distributed. So you run in a serverless environment if you want it to be sort of ephemeral. You can run it in a cloud hosting environment if you want to run forever or whatever. You can use a combination of both. It allows you to do that. The agent DB is the core part of the system that handles, at least up until this morning, the sort of vectorization of SQLite. that allows me to use the SNW whatever algorithm and do really fast sort of querying using vector space within SQLite. It includes a reasoning bank and self-learning capabilities. And it's a pretty good system. I have been using it quite a bit, and that's how I made this system before today, as smart as it is. So then I went, so the benefit to using Agent DB is now I can just plug in Agent DB. And as soon as I do the upgrade here, it'll magically get it as a dependency when I update the dependency to Agentic Flow and Claude Flow right away. So it makes it easy because it's a modular piece I can just pop in and it's already integrated. So it'll be trivial to do the update. I'm literally just changing a number and probably just adding a migrate option to the system. So before I get there, I'm going to start with the most basic core, which is Agent DB here. So you'll see here I said switch to the branch. So this is the Claude Code web branch. And I got that basically going here and clicking this little copy branch to clipboard. Then it switched to that because I was too lazy to do it myself. And then you'll see here I've successfully switched the branch. I've synced it, looks good. Now I tell it to review the plans. Now these plans were built in the previous swarm that I had running. So this is basically was Claude Code Web. So this is the AgentDB v2 RU vector integration plan. So you see how again in it. This looks good. Auto detect backend. I love auto detects. I don't want you to have to do anything. I don't build this stuff for people, right? I build this stuff for agents to use. And everyone's like, why do you have so much random crap in your wiki? Well, it's not for you, it's for your agent. If you're not asking Claude Code about my system, then you're doing it wrong. All right, so this is the integration points looking good. Legacy only. This is good because there's reasons you want to use legacy only. The old system is amazing. It's light, it's fast, it's great for sort of individual things. It'd be really good for like starting up really fast ephemeral agents. Let's say you want an agent to run for half a second. You're going to use the legacy system. You know, you could use the other system, but for certain things, you just want it to be smart, fast, for a moment in time, or you could combine the two if you wanted. Now, here's the feature matrix. I'm adding tiered compression. I'm adding GNN self-learning, graph queries, distributed mode, and WASM fallback. Here's the performance targets. It's way faster. It's better throughput, more enterprise. Project structures, blah, blah, blah. We can look at the architecture, system architecture. This is the system as it's set up. It's using my Rust implementation in Node.js. And how I'm doing that, just for you so you guys are aware, I'm replacing the Chromium runtime in Node. You'll see here I've got bindings for each of the major platforms. These bindings essentially let me use the native Rust in place of Chromium. So when you're using these agents or these NPMs, you're actually using a native Rust binary, which is just it's way faster and more effective than using the sort of native Chromium in run V8 runtime or whatever they call it. So I'm compiling each of these things specifically for each of those platforms, and then and deploying those as node modules, which you see here as the node core and node GN and so on. So it just uses those. Some more architecture stuff, blah, blah, blah. All right. It's done. It looked through all these things. It saw the security checklists. It saw the benchmarks. Now we're going to go down and it finished. And this took literally, I think, 15 minutes. So this is what my state-of-the-art agentics looks like. This is what I can do in 15 minutes, essentially. So now it created the alpha. It auto-selected 12 specialized agents. You'll notice that I never told it how many agents it needed to do it. It's now smart enough to figure out how and what. It used Claude Flow with the persistent memory. It's using all the tools. It created about 2,000 lines here. Now, the reason why the lines are so low is because I've already created these modules. I've given it everything it needs. It just needs a little bit of glue to connect dots, which means I'm doing it right. The hallmark to good systems isn't lines of code. It's the least amount of lines of code to get to solution. So the fact that I created 2,000 lines of code to do all this, it means that my modular approach is working, right? It's simple, not a lot of things to debug when there's only 2,000 lines of code. I can look at every line and understand it, right? And yeah, minimal viable code. Exactly. So when you hear people bragging about the fact, which was me like 6 months ago, I can do 10 million lines of code in a month. You know what? The real thing I should be bragging about is I did all this in 2,000 lines of code. That's what we're actually bragging about. So 15,000 lines of production code. I think this stuff is secondary. Um, all right, what else we got here? So metric. So it's self-tested. Search latency is actually 61 microseconds. 47 inserts. I gotta double check this. This number is exactly what it predicted would be. That's a warning signal to me. So I'm gonna do a little more detection. So now what I'm gonna do is I'm gonna look at the swarm summary. So this is giving me a kind of overview of what it's built in the swarm. So I'm always looking and trying to understand what it's doing. I'm not blindly accepting the sort of ideas and information it's giving me. Oops, one sec, guys. I'm questioning it. So now we got the different agents. This was dedicated to HNSW backend wrapper, reasoning bank migration, skills library migration. So I'm getting all the best bits of the stuff I've already done, and I'm applying it now to the root vector system. One thing compounds on the next thing, making the next thing better and better and better. All right, so we're getting the performance. So I'm seeing. So now I'm just gonna do another. I'm gonna say, um, prove this system isn't fake, BS, or simulated. I have a reputation to uphold here. I don't know. So now I'm just gonna just push it and test it and remove anything that might be mocked or fake, or there's always gonna be stuff. But again, the fact that there's only 2,000 lines of actual integration makes that process much, much easier. So yeah, all kinds of interesting things. Now, if you want to use this system, all you need to do, like you'll see there's an examples folder. I got some crazy stuff coming. One more project that I'm working on that you guys are gonna like is I've created a clone of MathPix, the OCR platform. And why is it not loading? Maybe we'll come back to that. Basically, I'm like, all right, everyone's like, well, how can we do the world's best OCR with your crazy platform? So yeah, I built that. Just Claude Code isn't loading for some reason, so we'll have to come back to that. But if you're curious, you can go here. You go to the code, and we go to branches. You know me, I'm an open book, so you get to see everything I'm doing. This is MathPix clone. All right, let's see where we can find. I think I put it in examples. MathPix. I could probably change the name. Fairness to the guys at MathPix. All right. So MathPix with WebAssembly. So this is a high power browser-based OCR system. With GNN and all the other crazy crap I was just showing you that can parse images and documents, doing all kinds of stuff with it. I haven't had a chance to fully read through it yet, but what do we got here? Let's go to docs. What the heck is it? There's an API server. Let's look at the benchmarks. That's probably the most interesting thing. Comprehensive performance benchmark for the OCR platform using Criterion. Single image OCR in 100 milliseconds, batch 16 images in 500 milliseconds. I've integrated my Lean 4 proof system. So there's yeah, where's the Rust ecosystem spec? Let's go to spec. It's a this is optimized for highly technical schematic OCR. So why would you want to use this? You want to use this for things like doing analysis of like radiological analysis for cancer. You want to use this for scribbles from a doctor. You want to use this for mathematical proofs that you do in a academic environment. You want to use this for, things that are highly technical in nature, and there is no room for hallucinations because someone might die or a rocket might explode, that sort of thing. So converting research papers, digitizing and doing that ridiculously fast, right? And this is built in on top of all the other stuff that you see. Then I'm doing automatic detection of mathematical structures, algebraic notation, arithmetic, and then I'm proving that using a Lean 4 implementation that sits in the system to actually not just take the information, but it'll do real-time nanosecond proofs of that. Like, this is totally sci-fi, right? It's so crazy. All right, I'm gonna stop for a moment and let Chris take over and see where he takes this conversation. That's my week. All right, where's
Thank you,
my
Ruben.
How you doing, Chris?
I'm doing great. I guess we can start off with what I built last night. So I have come up with this idea for a thing called teleological vectors, and I wrote a whole dissertation on it. But what I did is to test this out, I took 1,000 calls from customer service calls. And this is for like Medicare customer service, right? And I took these calls well, I'm in like a different branch right now, but let's see here. Okay. So what I did is I took the calls and I embedded them. Okay. And the way that this works, I guess this isn't showing up right now, but basically this is what I said in this box here. I said, I was setting a North Star, right? Because that's what teleological vectors are. You set your goal, your purpose. Basically, what this allows us to do is it allows us to quantitatively measure with math things that human beings have never been able to quantitatively measure with math, such as purpose, goals, emotions, intent, almost any of these human actions. All right. And so my North vector for the customer service calls would be every customer interaction should leave the customer feeling confident their issue will be resolved. Agents should demonstrate empathy, take ownership, and provide clear next steps. Okay. And that's what this is right here, this yellow North Star. And this shows the calls that rate close to the North Star. And then right here, we have like dialogue. So the North Star here is a description. Then we have dialogue. Dialogue would be like, if you're like a company, a customer service or sales company, you have like set rebuttals, things like that, right? Those are the dialogues that we're measuring against. And then we have the calls that are just far off a track from, say, the North Star or the dialogue. Okay, so we can zoom in here. And well, used to be able to like rotate it and stuff, but I don't have it connected right now. And then we have like the errors, right? And so let's take this call 0221 and one of these calls from right here around, say, the dialogue point, right? And I took the calls and I put them into Gemini and I asked Gemini, describe what's happening in these calls and compare it to, say, the North Star, right? And so this 0221, this is the call right over here by the error. So what's happening over there? Why did it show up over there? And this call is a near perfect embodiment of the North Star. Despite a rocky start, hold time, and audio issues, the agent navigated a complex, multifaceted request with a high empathy, extreme ownership, calculating custom quotes, bringing in a subject matter expert, and crystal clear next steps. So even though they executed the call perfectly, it identified the audio quality and the whole time as a mega issue, right? And so that flagged the call. So these calls over here are going to be like flagged calls that are like way out of the normal. So you can tell when, say, something goes wrong with one of your customer support agents or sales agents within, like, say, 30 milliseconds of a call ending, rather than waiting for, like, a weekly or monthly or quarterly review or whatever that might be, right? And then we got the calls over here by the dialogue, and say right here 0152. And 0152, the call fails to fully meet the North Star. While the issue was technically resolved, an appointment was booked, the interaction was purely transactional. The agent lacked empathy regarding the customer's pain, and took only passive ownership and provided no recap or specific next steps other than confirming time. So basically what these calls are right here are the people that are following, say, the rebuttals, but they're not being empathetic. They're just kind of going through the motions. They're just doing the job, just sitting there for a paycheck. And that's kind of what this area kind of represents. And then you have the calls that are, say, like 0589, that are like right there on the North Star. These are going to be calls where you're solving the customer's pain points, you're being empathetic, right? And those calls, for example, 1 second, scroll down to that call here. And what happened in, say, that call, it's around here somewhere.
Whilst you're searching for it, Chris, I mean, how did you actually, how are you relating it to, like, the intangibles, like empathy and others, like,
It's through vectorizing and math, and weighting, some things like that. And so the call that's perfect, it's going to say that was like right next to the North Star. Well,
So
it has.
what about in regards to your empathy? Like, empathy is one of those sort of somewhat subjective components. Like, as a human, you're empathetic because you have the ability to sort of perceive yourself in others, right? Which gives you a little bit of empathy in terms of putting yourself in their situation, if you will. AI doesn't have that. It has a manufactured construct of what empathy
But
means. If you're using an LLM, it's a probabilistic structure on top of it. So what's the math when you say math? Like, where is it doing it? How's it doing it?
it's when it embeds the vector, right? It's the North Star vector that I embedded, right? So the
Yeah, but
embedding
is that psychosymbolic? Like, it's using some sort of formulation? Like, it can't just be math.
it is
Empathy
just math.
but how do you
But
quantify it?
it's linguistics too, right? So it's all the words
Linguistics
around
doesn't
each other.
but linguistics doesn't define empathy. Linguistics describes empathy, right?
Like,
You are happy, but
so
it
this
doesn't
is
understand what happy is.
so this is a combination of, like, empathy, taking ownership, and providing clear next steps, right? So this is what this vector is. It's a combination of these things, right? And it's kind of like the center point in the space would be this, right? In the
Be
space,
careful. Be careful with this. If
right?
this is one of those fundamental problems that we face in AI. When it's very easy to sort of psychologically manipulate people, not by choice but accidentally. And when we start playing with empathy, and you see this with the sort of suicidal problems we see with ChatGPT, there's a reinforcement loop. And when someone goes into a sort of negative thought process, it might not appear to the AI to be a negative thought process. And that's because of the differences in the way we describe, the way, we think, language constructs, and, different languages work differently in when it comes to sort of empathy, right? Some certain languages treat empathy differently than others. And the AI is trying to create a probabilistic sort of view of that across all languages, but it's predominantly trained on English. So what you have to watch out for here is like the mechanism it uses and how you measure that, because we could mistakenly create a zombie army of people who are, we believe to be happy and content, but are actually just the opposite.
But then,
Okay.
Chris, if
So,
you are, so Chris, just to labor on that point a bit more, I think if you are, on the other hand, looking at it from customer satisfaction point of view, right? So you are saying is that I am a training man. This problem is common, like in many utilities companies, for example, who are struggling with this at the moment. where lots of complaints and you need real-time interventions. So is your motivation therefore to kind of train people to make
Yes.
sure that you end up? So have you tested this? Is it
Well,
simulated data or is
this
it?
this can help you track who needs training, right? This is like to flag things, to let you know who's doing good, to track progress, track improvement, know when things out of the ordinary go wrong. Like, for example, here in this one, I used so as my North Star, instead of demonstrating empathy, take ownership, and provide clear next steps, I set the North Star as every customer interaction should leave the customer feeling mad that their issue will be unresolved. Agents should demonstrate aggression, not take ownership, and not provide clear next steps. And so that was going to be one of these calls right around here. And then I put that call into Gemini and said, how does this align with the North Star? And it said this call that was next to that would be, this call represents a passive customer service. It acts as the antithesis to call 221, which was like the good call. And while the agent provided accurate information, they failed to take ownership of the transaction. They acted as a barrier to the sale rather than a facilitator, pushing the customer to self-serve on the website rather than helping them book. And what happened is the customer just didn't speak English. And so they were just not wanting to deal with the customer and just kind of brushed them off, right? And so you can set different North Stars, multiple ones, and you can do all kinds of different things with that, right? But this is basically going to flag all the different calls like that, right? And then you can pull up the call, you can look at it, you can have an AI, review it or whatever. But you'll know when these things are happening, like within 30 milliseconds of them happening, right? And
That's awesome. Yeah, I love what you're building here. And I love the way you're visualizing it. I could see visualizing a lot of the stuff that I'm doing, like this idea of neighborhoods. You've essentially created the neighborhood concept and you visualized the neighborhoods, and it's awesome.
Yeah, Claude Code just like one shot of this in like 5 hours yesterday with like this like spec document I created that's like build AI based specs and tasks. Just created it, completed the task, and it literally just ran with no issues. Instantly
Yeah,
had like
it's
perfect test
spectacular.
setup and everything. Yeah, it was great.
What I'm curious, if you
Mhm,
pointed at all the stuff I was showing you earlier, you should point
mhm.
at that and because you're using Neo4j. What's your graph here?
This is just UMAP, man. And
Okay.
and graph, and they're just taking the 768 dimension embedding space and converting it into a 3D visualization.
You should switch to the 384 and
The
then run.
768 is better for what I'm doing.
You need so many. I don't think you don't need that many dimensions. Not at all. For what you're like, why would you need so many dimensions? Like, what's the advantage? It's
I don't know.
computationally heavy, and you can bet most of that in the
Well,
neighborhood
it's not that
concept.
heavy. It's only like 500 megabytes for the Nomic model, right? And it can fit
It
inside
would
a browser.
be
There's an
almost
ONX quanted version of it that's really light.
okay. And so you're not running any kind of like embedding. You're just using sort of local embeddings. Like you're not using a service or anything.
Yeah, just local embeddings. Just took the calls here. They just embed in like, I don't know, like 20 seconds for like
All
a
right.
thousand calls.
Well, regardless, you can run mine in any dimension structure you want. So if you've already got it, I'm just curious what it would do more than anything.
Hmm. Yeah, these are all like 30 to 60-minute calls. They're like pretty long. And yeah,
That's pretty cool.
so yeah,
Nice,
that's what I was
nice
working
work.
on.
All right. Well, good. You're always creating all kinds of crazy cool stuff. I love seeing your demos. Yeah.
I just want to mention something, Chris. I was looking at your video like 1 hour ago, and the first thing came to my mind was um, this will be as a base to prepare bots, like for answering
Yeah.
and be on that level of the best possible.
So
So I think
that's
it
exactly it. So with
more
AI,
more than
mhm,
more than using it in humans because it can be badly used. It should be like identify specifically for that particular company or whatever that company is
Yeah.
offering, to train bots to be able to perform as the best for
Yeah.
answering
So
technical issues or whatever.
I'm gonna
That's what
have
came to my mind.
all it takes is putting in a sentence or a paragraph or whatever or your standard operating procedures to like set these embeddings. So let's say that and you can keep your AIs in line with this, right? And so let's say that you want your AIs to answer either somewhere near this star or somewhere near this star. Well, if an AI throws out an answer that's somewhere out in left field, well, the answer can be embedded and checked against this in just a few milliseconds. And then it can be forced to like re-answer, right? So that it's forced to stay within such, distance, cosine similarity distance of your North Stars, right? So you can force the AI to not be able to answer outside of those regions. Yeah. And you can control, you can keep all of your AI agents aligned so they're not ever steering off a course.
Yeah, that's awesome. And you built it, and I'm just gonna build something because I can, it's if you'd shown that a year ago, that would have been like, mind blowing in itself. Now it's just like a random Thursday kind of, why not?
Yeah.
It's just crazy, right? And people are like, people are debating AGI. Like this is it's going to be a thing. What's it going to be like? Well, imagine a world where you can create anything you want on a Thursday just because, and it's groundbreaking, never been done before, and state of the art in terms of all its capabilities. Oh, AGI is still off for sure. I think applied in certain vectors, like what can't you do right now? Really? Yeah, it's we're living in amazing times. All right, so this is the open side of things. Kind of pre-casual. Anyone have anything they want to present? Maybe they want to, go in the you want to rant. I don't know. This is your opportunity to
Yeah,
speak up.
yeah, this is Mark here. I've chimed in a couple of times. Camera's not working at the moment. Um, but I was wondering regarding some of the workflows. The recent one you just came out with, it's is it similar or how different is it from the agent DB, the Rub vector stuff you've got? I don't know if you've
It's
explained this earlier. I just called
That's
in.
okay. It's a direct evolution. So I learned a lot from Asian DB, and it's actually spectacular. And for what it needs to do, self-learning, self-optimizing, a lot of the same stuff that Chris was showing you. It creates a graph. It uses optimized vectors, etc. But what it didn't have was this idea of an attention mechanism directly built in it. Attention is all you need is attention, I think is the famous paper. So when I added the attention, it suddenly gave it this sense of self. And then I'm like, what? This thing can do all the crazy speed things that Chris was talking about, but understand how and why and what, and optimize and learn and adapt and evolve
Got it. And
as without any guidance.
cool beans. And then I was so that it's kind of tangential to some of my research. I was wondering in the Discord if you have like any specific areas to chat about this stuff. Because I basically have been trying to integrate some of my work with your work to just kind of find the balance of certain workflows that I use.
Yeah.
With that said, I do have some optimizations I'd like to share at some point, but I don't
Yeah.
know
Well,
where
let's
to do that.
okay. And discord.agentics.org. It's probably a good spot. I'm gonna pop that in the text area. We have a WhatsApp, which it's more active, but it's maxed, so it's hard to. I've got trouble adding people because there's a lot of spammers, and discerning the good from the bad is almost impossible at this point. But it is more active, unfortunately. So Discord probably is your best bet, and then on Discord, shoot me up your WhatsApp, and I'll get you guys in or reach out to Rob or there's David's on here. Anyone that's already part of our WhatsApp, and then they can help sort of invite you in, kind of thing. But otherwise, I'm not really sure how to get you in.
Oh, no,
Please
yeah,
excuse
I've
me.
got that WhatsApp. I was just wondering if there was a specific uh designations. But yeah, all right, that's all. Thanks.
No, we don't have any more group. Well, there's a consciousness group that's kind of fun for this sort of thing. That's a separate WhatsApp channel that there's a us that are interested in conscious constructs described. Very philosophical. That might be good for you as well. But that's
All
not part
right.
of either of those two groups. Antoinetta is the admin on that. If you know Antoinetta or anyone else that's on here, might know.
Please
Okay.
excuse me for interrupting without raising my hands, but I'm
No.
struggling to find out how to raise my hand in the Zoom app. Hello, everyone. My name is Dennis Hunter. My son was kind enough to purchase me a M3 Ultra Max Studio with 512 gigabytes of RAM. And if you guys know how much those things cost, you know my son loves me very much
Oh
and
yeah, nice.
makes more money than he should. But so I am on the path to learning much more about LMMs. You have definitely inspired me to go further. I actually teach AI, and until I met you, I thought I knew something. All I ever did was write a book on clusters for IBM, on Linux clusters, but obviously you are the man.
Yeah.
So,
Well,
with my new toy, what is the most wise thing to do as I move towards learning LMMs?
get yourself like LM Studio or one of those, right away. And
Okay.
what that will LM Studio is simple. It's a good starting point for running your own local LLMs and other models. But what I like about it in particular, it's got a really nice integration for MCPs and tools. So what you can do is you can create up your own you can host your own sort of super cluster using it, where you combine all the crazy stuff that I'm showing you as MCPs, and you run probably Kimi or one of those types of models, whatever the model that suits what you're looking to do, best, and that becomes the hub of that computer, right? Now you've got access to the tools. So now you're going to install probably probably Docker, maybe a nice Docker desktop and the Docker CLI, and then you're going to make sure you enable the GPU components there, so you can do the pass through KVM or whatever it is. It makes it way easier to manage this stuff. Next, don't use freaking PyTorch for doing your GPU stuff. It's cumbersome, it's slow, it takes forever to install. Move all of it to Rust-centric GPU libraries. Then get Claude, get anti-gravity and get Claude Code. I love Claude Code. You guys know that, obviously. Get Claude Code working, Claude Flow working, some of the other things, and you've got the world's most powerful computer, bar none.
Thank you for that.
Yeah, that you're living in the future. You got to get like a hacker cave with and someone's doing a heist. They show up. You're that guy. It's the
I have
ultimate
to share
hacker.
this. I have to share this story with you real quick. When my son was younger, I challenged him. I said, "You'll be a man when you can afford to buy my toys." So he purchased this, and he wants to know, "Dad, am I a man now?" I'm like, "You can
He's
spank me."
Yeah, he's the man. He's 100% the man. When my son shows up and buys me a $10,000 computer, I'm gonna be a pretty happy guy. Yeah, that's you're a lucky guy.
Hey,
I'm
hey,
jealous.
hey, Ruben, this is Dave. We got a quick question for you. So you said earlier that you really transformed, was it the Agent DB system when you added attention to its capabilities, right? And then you quoted the famous 2017 paper, all you need is attention, which is great. What a lot of people, I don't know if they may realize this or may not, is that attention is an actual real concept that lives in the transformer code, right, within the GPT. It's the T in GPT, and attention is actually like real matrices and tensor operations that actually are flowing through the transformer network, right? They're weights, they're key value matrice weights, the famous KQV matrice weights. So we know where the attention physically lives in a transformer, but what I'm wondering is how did you add attention? What when you say you added attention, is it that attention?
Yeah,
That
I had
that
tensors. I
you add
had tensors. So, and then I put the tensors on the edge of the hypergraph. Then I fine tune each tensor independently from one another. And then I apply the GNN, what's it called? There's a commonly defined sort of GNN attention approach that works since been used for like a decade, actually. GNNs were one of the first models that were created. They predate the LLM, right? We started with GNNs, and then we realized that we actually needed to be able to communicate with these systems more efficiently with natural language, and everyone went all in on LLMs. But what's the GNN is, to Chris's point earlier, is math. It's mathematics. It's calculus. It's and the what I did, which is taking the concepts of a GNN and then describing it in a higher dimensional space. In my case, 384 vector space, and then having the system capable of interacting with both the vector and the sort of whatever you want to call the graph space in parallel to one another, right? So I'm applying the attention to the index in essence. The index is the you can think of the index as like the synapse. So if you want to use an analogy of each node has multiple edges, that's the agent, right? That's where the logic lives and can perform different tasks for different reasons. That is able to communicating with all the other nodes that are also similarly distributed into neighborhoods. And there's introspection both in the data that sits in the node, but also the communication channel between them, the synapse, if you will. I created a streaming system that allows for instant sort of visual, like understanding of that flow of information alongside of it. So that they're working together with self-awareness, if that
okay.
makes sense. Yeah,
It
but it
sounds like, but that sounds like a transformer model.
it is a transform model. It's a transform model applied to a graph vector space. So
Okay.
it's 100%
Okay.
a transform model.
It's like
Yeah.
Because it
mapping out the back propagation of a transformer, if that
right.
simplifies it for you.
Because intention is basically a score computation across matrices, right? You're just literally compute, it just literally computes an attention and ultimately ends up with things like the softmax calculation.
Yeah.
Yeah,
And then
like how I'm using attention in that system I just showed you is the North Stars, like are like gravitational pulls. They like pull things to it, and that's how I was able to graph it out. And so I plan to add attention in the future. And what this is going to allow me to do is say, make it so that different transcripts could naturally align with different North Stars better. So, like a sales call might need persuasion weighted higher, and like a support call might need empathy weighted higher. And attention will allow the system to just dynamically learn that.
you've got attention. You already have attention in your model.
Mhm.
Your
Yeah.
attention is applied through the language model itself, where you're essentially requesting a kind of interpretation of the information you have in natural language. That
Mhm.
in itself is the attention model that you've chosen. The problem with that attention model is there's, especially in novel new areas, is a tendency to just completely make it up. And it's really difficult for you to see that based on that model, because you're literally going to measure that sort of drift, if you will, from real to fake based on asking it if it's real or fake, which is only going to reinforce whatever bullshit it's giving you. That's the problem with language models, right? So the attention that you're describing as kind of, I'm going to apply secondary attention, is applying that in a way that's verifiable, independent of the language. Which is sci-fi, right? It's just all sci-fi. Every time I get on this call, I feel like we're in some sort of sci-fi universe or something. It's just like every day it's crazier than the next. Now, again, the key here is this just proof. Like, and you can see here, like, let me share my screen and go back to the proof. Like we've got, I'm just like, no, this can't be real. So then I spend, all this time basically just trying to prove that the thing does what it's supposed to do. And that's the last step here. I'm actually ready to publish this package. The code doesn't exist on disk, compiles and runs. My reputation is safe. This is a legitimate production quality implementation. And then it created a whole document here that basically guides me through why it's real and how it works, file systems, checksums, actual code samples, implementation of the root vector backend. So it's giving me the stuff that I need to feel confident that I'm not gonna make an ass of myself. My most famous freaking Reddit was someone saying that my Wi-Fi disperse system was bullshit and look how stupid the vibe coders are. Yet the damn thing worked. So I want to make sure that I'm not in a situation where I can't prove the stuff I'm building because that was unfortunate. 2 million views of that stupid post too. But anyway. Um, Swarm coordination evidence. So this is how the swarm looked at it. Here's the technical proof. So here's the auto backend abstraction, the automatic detection, optional dependencies, dual mode controllers. This is the now we can dig into the neural net as well, and that might be worth exploring. Like we could like how does the attention mechanism work in the GNN?
Quick question. Have you tested out integer only frameworks? Like no
Uh,
floating point drift?
a little bit, what are your applications? Like what are you trying to do?
It's pretty similar to the topology mesh. Basically, um, think of it like a holographic FPGA computer I'm trying to develop.
Mhm.
So that way memory can be holographic, and then you can start deploying on holographic memory. So since this framework's
That's
all kind of similar in terms of information compression, theoretically, it should work given any
Yeah,
computer constraints.
that's an interesting idea. So you're talking holographic data structures.
Yeah.
And now that's a rabbit hole that I can't help but look at. All right, so let's go to where's let's go. I'm actually gonna continue the last session and because it's got context that I want to kind of combine. So I'm just gonna create a new sort of branch of that. Give that a second to do its thing. And this one is currently doing some research to let me know how my graph neural network attention mechanism works. Oh, we go. Reserve 41. I think it's this one. All right. Now, give me some ideas of the benefits of data structures using. I should probably do this in root vector, but whatever. Using agent DB v2. What else did you describe? What was the integer based? What was it that you said?
Yeah, you know what? Include integer based constraint. There's two identities. One of them's the
Base
Lucas identity
constraint.
for like Lucas numbers, and then the Benet identity for Fibonacci
Yeah, there's
numbers.
you gotta have to paste that into like the chat
Oh yeah,
area
I
or
gotcha.
something. Yeah,
Sure,
I
sure.
will. I will. But yeah, my brain isn't as fast as the AI here.
Yeah,
All right,
I'm
let's
sorry.
while that's going here, let's take a look at what it said for the GNN. This is to David's comment. How the GNN works in Agent DB, practical explanation. So user searches authentication, gets embeddings, finds nearest neighbor, returns results. Problem the querying embedded is static. It doesn't learn from context or past searches. The GNN enhanced search authentication gets embeddings, finds 20 nearest neighbors. The GNN attention mechanism, the magic, okay. Multi-headed attention, which I described earlier. Each head learns different aspects, security, code, tutorial, references, and relevance. Compute attention does the weighting to, which is what David was describing. OAuth, JWT, login. So this is contextually aware based on the information, like it could be DNA information, whatever. Weighted aggregation, enhanced query, nearest neighbor. So it's using a neurosynaptic pathway. literally a neurosynaptic pathway to describe different neighborhoods in the structure of the neural network based on the vector space, the distance between the elements in the vector space, and a secondary network of hypergraph components that exist within that higher dimension that can be interpreted independently of the higher dimension.
Yeah, so this is an optimization of the traditional transformer module, multi-headed transformer module, where you stack transformers to build up attention, doing softmax operations across attention blocks. But each one of your attention blocks are you're grouping them into neighborhoods and then giving them a specific focus instead of like a normal LLM where they're all trying to basically figure out next token prediction.
Yeah, yeah, essentially. So I did a multi-level attention system, both
Yeah.
latent. I'll call the higher dimension vectors latent space. It's the quantum realm, if you will, and the graph is the representation of that reality. It's the physical manifestation of that higher dimension.
Yeah, so you have different things going on that are being tracked in your attention, multi-layered attention uh, thing that you just described. Whereas normally in a transformer, it's basically looking at a string of tokens and just trying to figure out the next one. So it's very singularly focused on one task, right? Whereas you're having it focus on you've optimized a structure that has lots of different focuses all going on in parallel.
Or is it not more of a daisy chaining? Daisy chaining in the sense like you referenced, David, about the different context or where there are, I mean, I might be misunderstanding it entirely, so my apologies if I am. But if you are stacking up the transformers and you are related to a specific context in the graph, right? Is it that all the knowledge you are then kind of daisy chaining to create a super context? So when you say
Well,
I don't know what.
interestingly, transformers don't use any graph structures. They literally use matrices. That's all. Right. So one of the interesting that Ruben's done here is there's a graph structure happening inside and between the transformer networks.
Yes.
And that doesn't happen in a traditional
I don't think I can.
multi-headed
I can't find
attention
anyone
block.
who's done this. Look at research any existing platforms or systems or research studies that have implemented this.
Yeah, this is
No
kind
one,
of this
no,
is
no, no one's ever done this. This is way out, and if this is left field, I'm up by Pluto on this one.
yeah. Normally in a transformer and the multi-head attention layers blocks, it's just lots and lots of thousands and thousands of matrices, rows and columns of numbers, not
But you
graph structures.
but you're still predicting the next token at the transformer level. What I was saying is that the
No,
prediction of
no, I'm not predicting tokens at all. There's no token. The token isn't. It's
It's a causal structure.
it's a causal.
Well,
It's the loop. It's the loop. I'm doing microsecond, highly efficient causal loops. We're talking sub milliseconds, and combining those into sub matrices and graph structures based on novel forms of mathematics that events as it goes, and then qualify and quantifies using various forms of cryptography like the ED2551 spec and other forms of ways to prove it. But it's creating that almost instantaneously over and over and over again, using that as a mechanism to define what it needs to know and how it needs to work, and then creating these sort of patterns that are saved and learned and optimized in this crazy nanosecond sphere, and then adapts and gets better as it goes. Stupid day one, it's a baby. Minute 5, it's now super genius, and then continually gets and better.
Yeah, and what I'm trying to get to here, both Mondeep and Reuven and everybody, is that we do this is I say this every time, right? We are the largest cohort of the most cutting edge people in AI, in my opinion, outside of the foundation labs. And so I'm trying to figure out, have you invented something here that is actually novel a novel architecture, optimized architecture for the traditional T in GPT transformer, multi-headed transformer blocks. Is this is a new
Well, no,
novel?
it's pretty. I would say yes. I can't find anything like it, but there's one part that I'm not even describing. I've created a chip that will power this on a AA battery. That's the part.
Okay.
And not only is this ASIC chip ridiculously memory efficient, 256 cores, it embeds the WASM directly in the silica, and essentially at that point I'm able to run these things on like a thumb drive or on a watch battery. If I get this down to 2 nanometers, this will run on the current found in your brain. Just bonkers, right? And this is just scratching the surface of the efficiency you get when you don't use a brute force GPU intensive approach to AI where you get surgical and strategic in where and how you apply it, but do it in a super optimized fashion. It, for anything that involves any kind of like wave or mathematical construct or something that needs to be learned and inferred but not specifically described, which literally is the inner workings of your body, your brain, your biology, your other parts. This thing will just magically almost figure it out what and how it needs to sort of fit within that construct if you give it the data.
We should probably not use the word magical here. Okay.
It's 100% magic. How, like I can do my best trying to describe it, but there's this kind of emergent property that none of us can really describe why or how.
These things are very difficult to describe because there's a lot of math going on, a lot of concepts, and that's why I was just trying to really help everybody understand what's different between the traditional transformer and its attention blocks and its multi-layer attention blocks and what's going on here.
Magic is just how we describe science that we don't understand yet.
I don't understand.
True.
Yeah.
If you're quoting Arthur C. Clarke, yes,
Yeah.
definitely.
Well, we're building what Arthur C. Clarke envisioned, and Asimov and others. We're doing it. Like, that I brag about my Matrix call from a few months ago. Like, he calls me. He's like, "You built a swarm. This is what we thought the future looked like." Like, and he's the guy that did the sort of technical advisory on the Matrix movie. It's like, wow, that's something. So, we're building the future. It's happening as we get up in the morning, and as Chris decides to vibe code something, we're doing stuff that's just beyond our imagination in some ways. It's just I love it. I just love it. We're out of time, guys. Yeah, I hope you enjoyed my crazy as much as I do. It's been another one of those weeks.
Nice.
All right, and we have a hackathon coming up next week with our friends at TV5. So, use this. I'm sure we could, if a group of us come together and just point our stuff at, some of the stuff we built recently, we're gonna wow and amaze the world. And this is a chance for us to show off a little bit. So love to have you involved. Agentix.org/hackathon. And there's also an NPM I created, NPM Agentix-Hackathon, MPX, if you want to use the CLI. All right. Thanks, everyone.
Awesome.
Sure.
All right. Have a nice weekend,
And
everybody.
Thanks,
All
everybody.
right, have a nice
Happy,
weekend.
A quick
Happy
question for you, Rob.
Thanksgiving.
happy
Right,
Thanksgiving,
enjoy
happy
the-
holidays.
Thanksgiving
Happy
holidays.
All right,
please.
guys. I gotta jump. I gotta jump. I got another
All right.
call, and All
Carry on.
right. Thanks, everyone. Bye.